Hi everyone, and welcome to my talk on drones and artificial intelligence. I'm Adam Stephensen. I want to walk through a number of things today. I'm going to start off talking about some of the real-world solutions where we're seeing, government agencies, customers, and wildlife organisations seeing real value out of combining drones and artificial intelligence. But really what I want to get into reasonably quickly is showing you how you can get up and going as easily as possible with the drone and AI solution. So we're going to start off with the DJI Windows SDK, and then we're going to look at once we've got that up and going and running a machine learning model from a drone, then we're going to actually go and have a look at how can we actually easily build machine learning models without necessarily needing a data scientist. And then we're going to take it a step further and look at how can we take our machine learning models and just as developers actually go and run those machine learning models on embedded devices. And then we're going to talk about what's next, what's new, and a few of the challenges that we're seeing around drones. So I'm from Australia, if you hadn't picked it up from the accent. It's a 30-hour flight here, so it was a bit of a hike, but it's a beautiful country, so it was definitely worth it. This is the beach down the road from me. It's pretty nice, and I love new things. I love toys. So this is my favourite new toy. I've had it about a year and a half, and it's a 6.5 metre surf ski. I like new shiny things. I like getting into things early. I've been doing ASP.NET Core since it was ASP.NET 5. I shipped apps to production in Angular when it was still in beta. Sometimes I'm in early, and that's definitely the case with this drones and AI story as well. When you get in early, sometimes things don't necessarily go according to plan. And there's definitely a learning curve involved, and I found that with the surf ski, and I've found it with drones and artificial intelligence and that combination. So it's still early days for being easy to do, and that's kind of my one of my missions today is to kind of share with you how you can easily get up and going, and then what the future looks like. So when I bought my surf ski, it was a couple of steps higher than I should have bought. I should have got more of a beginner one. So I spent a bunch of time in the water, probably at the beginning more time in the water than on top of the water. Has anyone been to Australia? Yeah. I like Norway. I like coming to Norway. There's nothing here that's going to kill you. So I live in near the Gold Coast. This is a map of Australia and reporting the recorded shark attacks. I live where the 91 is. So I love my ski, I love the water, I love being on the ocean, but it's always there. You're thinking about it all the time. A guy with exactly the same ski as me actually got the nose bitten off his ski about 6 months ago where I paddle. So they're there, you've got to be aware of them. And, so that's kind of how this talk came about. Is I'm thinking about them all the time. I'm an application development specialist at Microsoft. My background's in web and enterprise development, but I'm actually spending more than half my time now building artificial intelligence and IoT solutions. And so I'm out there paddling along, looking behind me, trying to go fast, thinking about the sharks, and I had a bit of a brainwave. I thought, there's a bit of controversy where I'm from. We put shark nets on some of the beaches to keep the sharks away. Other beaches don't have the shark nets. And the reason is that, whales, dolphins, turtles all get caught in them. I'm thinking about that, and I had a great idea that kind of combined all of those ideas. And it was, what if I was to use some AI and put it on a drone? And what if I invented a drone shark net? And what if I could fly drones out and I could have them using object detection looking for sharks, and then people would be able to go out and swim, and if one of the batteries went low, then there'd be pre-charged drones, and they'd come out and they'd replace the ones, and we'd essentially have an artificial intelligence net looking over the water as a protection against sharks. So I thought, then that's actually started my whole drone and AI story, was thinking about this. So then I went back to work, and I'm chatting to my friends, and shark comes in, swimmers go back to shore. It's amazing what you can do with PowerPoint. And I started looking into this drone thing and seeing what stuff had we already done. And it turns out that we've already done, so at Microsoft and at other places, there's already a lot of this combination of artificial intelligence and drones already out there. It's just not enormously visible yet. So particularly in the areas of public safety and energy, construction, infrastructure, and agriculture, there's already really big investments and people doing really cool things. In the area of agriculture, we've got part of our AI for Earth program. We've got a program called Farm Beats. And what happens with, Farm Beats is a full solution. There's a lot of research going into how to use data and artificial intelligence and IoT to help farmers along. And so there's a whole lot of pieces to this puzzle. One of them is that there's a whole lot of sensors out in the field streaming back data about, about salinity and about how the moisture levels all over the fields. Then there's drones flying over the fields, and they're doing things like being able to find where weeds are. But there's also they're sending back data around different color spectrums where they can actually tell different areas of the fields where plants are more or less healthy. So we're really moving into this precision. We're helping farmers move into precision agriculture and data-driven farming. But when Old MacDonald had some data, I got some figures of what the day in the life of a farmer looks like today. All of those IoT sensors are sending about 70K a day back to the server. The cameras that are around the farm monitoring different things are sending about 28 meg. The drone imagery being sent back is about 5 gig. And the the video from the drones is about 10 gig per day being streamed back to the servers. Now, I don't know if any of you know any farmers. I know quite a few from where I'm at. And if I go to a farmer and say, hey, all you've got to do now that we've got all of this great video is sit there and monitor it, they're pretty busy and they're going to say some rude words to me. And this is where AI and all of this video processing comes in. Is what we're able to do, that we're able to generate actionable insights. And that's really the key, is we're able to go, let's generate all of this video and we'll process it for you and we'll just tell you the things that you need to know. And that's really key to all of these use cases. So not only are we doing a whole lot of investment in a whole lot of projects, there's a whole lot of partners out there doing commercial solutions. So Slant Range is a commercial solution that's out there and is very big in agricultural communities. And based out of Norway, it's great to be in Norway, and I've actually got to meet these guys. This is actually one of my favorite AI and drone combinations, and they've been doing this for a long time. So, and they're doing power line inspections. So what used to happen is that helicopters used to have to fly along close to power lines while people took photographs to try and define, where maintenance needed to happen. And so eSmart Systems, which is a Norwegian company, actually now has drones, and the drones are flown along the power lines, and they're using artificial intelligence to actually detect anomalies and detect work that needs to be done. So they're able to come up to a power line and identify, here's all the discs, and here is the top of the poles, which is what you can see in this picture. And once they've got them, once they've identified what they are, they're able to inspect them for faults and then categorize them for work that needs to be done later. So they can actually, instead of having, taking a whole lot of photos and then working out where all of those photos were taken and mapping them up against individual power poles, now that all comes out of the box, with GPS tracking, and they can, put together really nice maps of where's been done, where hasn't been done, where are the faults. So that's a pretty awesome system, and they've been doing this for a long time. So I've come along and I've put my nose in and I've found, wow, we're doing all of these amazing things. And I was talking about it and I was trying to work out how to do it and poking people and trying to get some assistance. And then as it turns out, a friend of mine said, there's some guys that do that in Australia. And it turns out they're about 5 kilometres from where I paddle. So after 2 months of doing research, I find out that a little Google search for my brilliant idea would have been really handy. So this is Little Ripper, and they are so this is their first version. They did a single rotor as their first a helicopter-based drone. And what it does, it flies over the ocean, and they've built it's actually a very complex machine learning algorithm that can actually detect sharks and a whole lot of manner of species actually in the water. So they're not too far from me. So I went down and introduced myself, and I'm actually working with those guys to help them out with a few things. So they have a very complex machine learning model because, as you can see, the sharks appear more or less as shadows. So it's not just a shape that they're tracking, it's actually the movement of that shape under the water. So they're also able to identify things like dolphins, surfers, whales. So they're doing, and what they're doing, so I like the one after this where you can see the shark swimming up to the surfer. Yeah. So these guys are doing some really great stuff. It's actually an award-winning machine learning model that they've got there. And they're doing it in two models. And their two models that they're deploying are very similar to the ones that I want to show you how to build today. So they're using small commercial drones. This is a Phantom. I'll be working in a Mavic, but it's the options that we're going to look at are available to both of them. So they're putting these couple of $1,000 drones in every surf club around Australia, all up and down the beach, because this is something that you can go and buy at a store down the road, and you can fly it without a lot of license or a lot of complexity. And if you do crash it, it's only a couple of $1,000s. And how that solution works is that the drone streams data back to a controller. So I've got my controller that comes with so what I'm talking about today is working with, this is just a DJI Mavic 2 Pro that you can get, it's an awesome drone. And this is the out-of-the-box controller that comes with it. And so what the number one scenario, the easiest scenario is, who's a C# developer? It's a fair few. So what happens is the drone's out flying, the drone's streaming data back to the controller. DJI and Microsoft have partnered to actually do a Windows SDK. So this USB is actually going out of the controller and into my computer. So I'm actually able to write C# code to take that feed and analyze that data feed. I should have called out right at the beginning, on the first slide and last slide of my talk, there's links to all the code I show is in a GitHub repo, and all of these slides are available for download already. So if you look at the diagram, the feed goes back to the controller's hooked up to a computer, and the computer can run a C# UWP app that's actually going to analyze a machine learning model and stream that out. Let's have a look at what that... Oh, sorry, I'm going to go a little bit further. So as well as doing that, they also do a couple of, they do a bigger enterprise version. So this is the one in the red and white one in the back is a 25 heavy lift drone. It'll lift 25 kilos. That's their version 1 drone. This is their bigger drone on their modern platform. So this is a DJI M600. It's about this big. It can stay up for longer, it can carry more. And what's really interesting about it though, is it can actually do the processing on the drone. Okay, so what we're looking at there on the top is a separate little single board computer that's mounted on top of the drone, so that now you don't have latency. That can actually tap into the onboard SDK and payload SDKs of the drone. So rather than transmitting data back and processing it, now you can do your processing on something that looks like a Raspberry Pi. I've got one here if anyone wants to come up and have a look. It's not a Raspberry Pi, but it looks like a Raspberry Pi. And I'll talk more about that in a little bit. What it actually is it's an NVIDIA card called a TX2. And it's same form factor as a Raspberry Pi, but it's got 256 GPU cores on it. It's made for edge AI processing. And this is an M210 DJI with an out-of-the-box manifold 2 on it, which has that exact card, just an out-of-the-box solution you can buy from DJI. So they're kind of the two models that are most common in this space, where you're sending data back and processing it, or once you move into the serious toys, but you're looking at 16 grand for the M210, or about 9 grand for an M600 without a camera on it. So you're going up to the next level, but you can fly them in any weather. If it's above 20 kilometers an hour, I think twice about sending my little drone out. These big ones are made to fly in all conditions. Interestingly, just as a bit of a side, it's not related to AI, but they've already saved a number of people's lives because when they send these big ones out, they actually have, see the pods on the bottom? They are actually life-saving pods. So they can find people when they're in distress and go and they drop those down, and when they hit the water, they expand. So it's pretty cool. So with that model, what's happening is we're actually doing the AI processing on the drone directly, and it's just transmitting that data back to the controller, which we're then sending out to the cloud. The more advanced version of that is to actually not need to transfer back the data for the drone to be able to talk directly to the cloud. Who can tell me what this is? Koala bear. The reason it's in infrared is that this is a drone project again from Brisbane. So this is my use case for the day. So that's enough talking. Let's show you how to do some stuff. We're going to build one of our use cases that we do in Brisbane. Unfortunately, koala bears are in big trouble. We don't understand why, but they are just disappearing out of the forests. There are whole habitats that used to have koala bears in them, and they're no longer there. What we used to do was we'd walk, koala bears live up in big gum trees. They are nocturnal, so they're not out in the day. They're not easy to find. What we used to do was walk around with dogs and try and, the dogs would try and find where the koala bears are. What we do now is we fly night missions over the forests with infrared cameras. And what the infrared cameras are able to do is actually do object detection on the infrared signature of a koala bear and map where they are in a forest. So it's easier, it's cheaper, and it's more accurate. So this is what we're going to build. Sound good? Yep. So, and I make it sound really complex, but that's kind of good. I'll let you think how smart I am now. But the key to it is it's not that it wasn't complex, but now that I've done it, I can do it easily many more times. So what I've done is I've taken two sample projects, one provided by DJI and one provided by Microsoft, and munged them together. Not necessarily as cleanly as possible, but it works. And I'm going to leave I am going to tidy them up. I was going to leave them together so that you can see the individual, but I'm going to do another project that separates them out. The first one that I downloaded, and I'm going to have to stop this sharing. So, if you're going to go and do this, the first thing to do if you've got a DJI drone, who's got a drone? Only a couple? Okay, awesome. The first thing to do if you're going to, so this only works for the DJI drones. It's based on their Windows SDK. It's the easiest one to get into. The next demo will work with any brand of drone. So if you go and go to GitHub, DJI have a Windows SDK which has sample code in it. When you run that sample code, it basically streams up to stream that video from the drone into the controller, into the computer. But they just give it to you. They don't do anything with it. If you are so I work a lot in the Azure space. I do a lot of programming in the cloud. There is an amazing sample application called the kiosk. Oh. No, I haven't moved anything. I just stopped PowerPoint from displaying. Do you want to restart it again?
I think maybe you just stopped sending.
Aha!
Because I didn't do sync.
Nope. I think we're back. Okay, you should be able to see now. Awesome. So you can just go and download the Windows SDK. That'll actually let you do a lot of other things. You can launch the drone, you can move the drone around, you can do a whole lot of things. Because I'm talking AI, we're really talking about object detection at the moment. You could move into autonomous flight and writing all of that stuff as well. But I'll do a talk on that again at a later point. So really, that gives us our streaming data. Then what we're going to go and get the code for the intelligent kiosk. So I'm going to show you my repo, which is a clone of it. So if you go to Microsoft Cognitive Samples Intelligence Kiosk, it has real-time driver detection, where if you run it, it'll show you if you're yawning, if you're squinting, if you're looking away, you're distracted. It has AI to show you all of that. It has, voice to text, text to voice. There's a whole lot of different samples in there around all the different cognitive services. The one in particular that I've taken and I've mashed with the DJI sample is our object detection. So if you come and clone this repo here, which is my version of it, what you're able to do I'm going to show you what it looks like when you run the code, and then I'll show you the changes that I made to make it work. So I'm just running the application. And what we're going to do, we said we're going to do a real world scenario. So we're going to find a koala bear. I thought, sharks. I'm in Norway. It's got to be sharks and koalas, doesn't it? Oh, hang on. You can't be Australian without a crocodile. So, sharks, koalas, and crocodiles. Okay, so here's the cognitive. So you can see there's a lot of other samples in there as well. The one I've done, I've just modified the real-time object detection to work from the camera stream. So I'm going in here to real-time object detection. It's now streaming my video from my drone. There we go. Oh. Now, this is actually really interesting. You're all a mob of wombats. And that's a really good point. We're going to can anyone tell me why you're all wombats? You can now go home and say, guess what? I got called a wombat by an Aussie today. Does anyone know why you're wombats? I trained on all animals and not people. That is exactly the right answer. We'll come back to that because it's really important. When I come in, so I've kind of got to do, so here is my koala. You can see he's identifying Mr. Koala, and I mustn't have Mr. Crocodile at the right angle, and there is my crocodile. Crocodile. There we go. There's the crocodile. Now, it's definitely a bit flaky in here. And we'll come back and talk about why in a minute. But as you can see, that's actually pretty cool. And this is how we've done a number of projects based on this same kind of idea. I'm just going to quickly run you through what's happening in the code there. I haven't talked about how to build the machine learning model. We're going to come back to the machine learning model once we've walked through this bunch of code. So this is just there's a single view called the real time. I can turn that off now. Okay, there is a single view that we're using. And more or less, there's only two things we really care about on this view. One is called a swap chain. You guys can see that, okay? One is a swap chain panel. Basically, the swap chain panel is a DJI control that enables us to bind streaming data to it efficiently. The other thing that we've got is a canvas, which is called a face tracking visualization campus. The reason it's called that is that this view is used for a couple of different demos in that cognitive kiosk, which is one of the reasons why I'm going to break it out and keep it separate. They're the only two things that we really need to worry about as we're jumping through the code. What happens when we fire up the application? We come in and we kick off the real-time object detection class. It calls initialize component. We have to register our DJI SDK. So there's an SDK key there in the code, but that's also to be refactored out. So all we're doing is we're coming through when we're saying, this is direct copy and paste from the DJI sample into my cognitive kiosk sample. And this is how you go through and you register an application. Once it's registered, we're calling the instance SDK registration method. The instance registration method is saying, well, if there's no errors, then come through and initialize the video feed module. If we have a look at the video, I'm just calling out the key points. When we do the video feed module, what we're doing is we're wiring up an async callback to say, when we get data, what do we do with it? Now, DJI supply you with a C# library called the DJI Video Parser. And this is, you don't have to worry about it, you don't need to change it, but you need to compile it and include it in your project. You could just compile it and link it, but I'm tinkering with it. So I've got it there, but you don't, all of this runs out of the box with no changes to the DJI Video Parser. The key to it is, this is all, once again, this is all more or less copied straight from the DJI sample into the cognitive kiosk sample until I'll show you the fun bit. And what we're doing is we're saying, we're setting up so they run through all of this code, and there's a point that says, go and set a callback for the received decoded data. Okay, so there's a method that they supply called receive decoded data, and they have no code in their sample application. And what we're doing is we're binding to say, when we get data in, call receive decoded data and send it to the swap chain panel. I found all of this clunky, and I did a version of this where I actually went through and I wrote it the way I would write it, and then tried to take their feed of streaming data and turn it into video frames and work that way, and I just ended up in a nightmare. So it ended up being, even though I don't love this code, it ended up being much cleaner and much more efficient to take their sample code, bind it using their control, and then just do my analysis over the top. So I know you're probably looking at it going, oh, that's not how I do it. It's not how I do it either, but it actually works out much more efficient. And I'd love if somebody else can give it another go and find a way, but for me, this worked reasonably well. All the magic, so this is all I had to do really. This is what's really nice about it, is I've taken our sample project, the DJI sample project, and all I'm doing is I'm saying, when I receive a data byte array, I'm coming through, I'm turning it into a buffer. From a buffer, I'm turning it into a bitmap. From a bitmap, I'm turning it into a video frame. And then, very conveniently, video frames are what the Azure Custom Vision SDK take to perform object detection. So that's the hoops. But it was more or less two samples put together. That's my code that hooks it all up. Once I've got that, I'm back into running the sample code from the cognitive kiosk. Take that video frame, and in this solution, you'll just see in the assets folder, there is a aussieanimals.onyx file. Don't worry about that. I'm going to make that with you in a minute. But basically, that's my magic machine learning file. I can put my magic machine learning file in the project, change the name, and now what's happening is when the video frames come in, I'm going to perform predict images. So what I've done is I've gone and created a machine learning model that can go through and it can identify crocodiles, koalas, and wombat. Sorry, wombat. It's not just you. You do look like wombat. And wombats. So I've got a bunch of images. I've trained a model, and now when I call predict image async, it's going to take the video frame that's passed that SDK, and it's going to return a prediction model. And the prediction model just has, here is a probability. Here is the tag name, wombat. It can only be wombat, croc, or koala. And then here is the bounding boxes. Here's the coordinates on that frame you gave me that corresponds to that tag. I've gone through it pretty quick. If you step through it, it's actually relatively simple. And it just works. I'm actually really happy that it's that easy. So you can, when I wanted to do a new demo, I did this demo just to come here. I do a safety demo where I fly the drone and I can detect people who aren't wearing hard hats. To do this one, because I'm not allowed to fly a drone in here, I literally didn't change any of the code. I just created the model, exported the model, and stuck it in there. Okay, so that's how easy it is. Pretty cool? And it's essentially a real-world scenario too. So I didn't do an infrared of koala because I don't think he'd show up very well. What I'm going to do is, So DJ, the reason that is easy now, I can do it in C#, I can do it in Visual Studio, and the reason is because DJI and Microsoft have a strategic partnership. That SDK is only at 0.35 or something. It's still actually reasonably early days, but they're working on it all the time. So I'm going to be really interested to see it get easier and easier, cleaner and cleaner, and more powerful and more powerful. Let's talk about how to actually go and build the model, because we've seen how the code runs. Now, building machine learning models. I'm not a data scientist. I'm also not a drone expert. As I said, my background is I build enterprise web apps has been what I've done for the last 20 years. And I'll talk more about data scientists in a bit. What's really nice is that we have this service called Custom Vision. So you can go to customvision.ai and log in. And this is the easiest way to build a machine learning model. It is not going to build you the machine learning model that generates, that's able to detect sharks traveling under the water. I'm also working on a northern hairy-nosed wombat detection system at the moment. Also involves a data scientist because there's a whole lot of, back quarters of wombats. And they're trying to do more advanced things, so you need machine learning and data scientists for that. But for a lot of use cases, this is going to get you into production and it's going to get you over the line. So you can see I'm doing a bunch of different, there's my safety one here. So what I did when I was coming here, I literally sat in my hotel room and I went, give me a new project. I came into the new project. I put actually it was before I left. I sat, it was here. I sat because the reason I know is I bought these on the airport on the way out. I literally sat the koalas. I sat the toys on the desk. I took a bunch of photos on my phone, and then I trained the model. So you can see I took a bunch of photos. I hit the train button. It actually builds you a machine learning model, and then I went into predictions, and I went and uploaded some more photos. And then they gave me a response to see how I went. And the predictions were pretty good. But then I ran the drone footage into my machine learning model and it was terrible. And that's because the images I took on my really nice Samsung S10 were bright. They were sitting on a desk in a very well-lit space. When I was flying the drone, testing them, I was in a Norwegian hotel, seemed to like mood lighting. So the lighting was completely different and it really didn't work well. And so this is my next tip and this comes back to the other question. The closer you can get your images that you train on to the input that's coming in, the better your model is going to work. If you're going to have a model that you want to use in a whole lot of scenarios, you need a lot more images. The nice thing is, so what I actually do usually with drone when I'm trying to build one of these machine learning models is I'll go fly the drone and record a bunch of video and then slice the video up to actually make my machine learning model, if that makes sense. And the good news is there's a tool that's going to help you out that makes life very, very easy. And it's called FFmpeg. So all you need to do is you run FFmpeg, you pass it the input video file, you tell it to do a filter and to how many frames per second you want. So this is give me one image every 2 seconds. And this is the parameters for the output. It'll take that video file, slice it up, and then put it all in a folder, and I'll show you what that looks like. So when I record video, so when I'm making one of these custom vision models, if I come and grab one of these, if I don't do safety, oh, this is code. If I go up into my models folder, if I go and do something like doggy finder, so I'm also doing one to train dogs. So here's the 4 videos. You can see I'll record multiple training videos, and then I'll record a testing video. And then I'll run FFmpeg, and I'll make a whole lot of training scenes, and then I'll create testing scenes. So then I'm never training my model using my testing data. Does that make sense? But it's the best way to build a model, because you're actually training the model on, because there's an out of the box model you can use to detect dogs. I found it doesn't work when you're flying over them at 40 meters. You need to train your own model to get that kind of thing to work. So that's my tips around. So that's kind of my tips around building the model. You can actually do it really, really easily and build really nice models. The reality is you need a few hundred images. The number of nights I've sliced up video and then put Netflix on and sat there for 3 hours going around. Oh, I didn't show that part. So once you've uploaded the images into your train, so you go through, you slice up the images, you upload them, you say, give me a tag, you hit the plus to create a tag, and then you go into each image and you draw a box around it and say, this is what a wombat looks like. Make sense? This is machine learning without needing a master's or a PhD in mathematics. And it gets you a long, long way. So it's definitely worth checking out. There's a tip, if you're running it on Linux, I'll just call it out because there might be Linux users here. The top line is what I do on Windows. It's actually processing every frame, but then only reporting one every 2 seconds. The second module is using the time command in Linux to actually seek ahead and only process the frames as you need them. Just if you want to get the slides, if you're processing, an hour of video, it'll save you a bunch of the processing time. The other part of it is just the portal's great, and I actually use the portal most of the time because these are fun projects. If I was actually going to do it for, I object to having to use a portal to do anything in production. What I actually would prefer to do in production is have a whole lot of images and have a whole lot of those bounding boxes, check them into source control, and now source control the source of my trained models. And that's what the custom vision.NET SDK is all about. So you can do it in .NET. I actually do it in Python because I don't have to compile it. I can just have scripts in my folder with all of my files, and I can then go through and you can say, here's all of the images, here's where the bounding boxes are for those particular tags, and now you've got all of your training data in source control, which is pretty cool. But if you're just going to go and have a play, Custom Vision, the portal is fantastic. Let's talk about, let's talk about data scientists. Are there any data scientists in the room? Okay. Hi. Hey, so I work with a couple of data scientists, and I work with a couple of them in customers. And now I understand what my mum feels like when I get together with my mates and I talk about architectural patterns in the kitchen. I didn't realize how smart some of my friends were, the data science ones. It is a different field. And I used to think that data scientists were like programmers, but I really appreciate what they do is a very different skill, and it's amazing. They're taking the statistics and the mathematics and combining it with some coding skill to produce these models that can do amazing things. However, and you guys can, this doesn't apply to all data scientists, but my big warning in here, who wants to know what my warning about data scientists is going to be? You want to guess? Data scientists are scientists. It's right there in the name. I'm an enterprise dev. I'm doing AI projects, but I want to ship an MVP. And the data, I work with super smart data scientists, but that's part of the problem. We'll have it working, but they'll go, if I did this and maybe what we should do is try these, and I've actually not understanding the next 60 seconds, then we'd actually work out what the best way to do it would be. And that is awesome, and there's a time and a place for it, but I feel like you've got to manage, this is going to get me in trouble with data scientists and designers, but you've got to manage data scientists like you manage designers. Designers are creative and they're thinking differently, and they're not as constrained sometimes and linear as programmers can be. Now I'm going to insult programmers too. But it is something to be aware of, because you can build the biggest, best machine learning model, but when you want it to run on something that only has a little bit of processing power and you need it to happen really quick, maybe it doesn't need to be the best. Maybe you just need it okay and you need it tomorrow. So it's just something to be aware of. But the other part of this is calling out is cognitive services gets you a long way. More than half of my real projects are using data scientists to do things that I don't understand. So this can often be a really good way to kickstart you, to prove value, to get the business involved, and to justify now we need to bring some data scientists in to make this really awesome. So I've covered the Windows SDK and the easiest way to get up and going. The enterprise way is to take that board that looked like a Raspberry Pi, but had its a de facto standard of 256 GPU cores in it. It is blazingly fast. And it's created by NVIDIA, and it's called a TX2. Raspberry Pi is a single core. They have a gig of RAM. There's really good, if you want to get into this, there's a really good Raspberry Pi demo that shows how to do custom, image processing running on the Raspberry Pi, and everyone's doing it. But you'll realize it's not the right thing to do because every frame takes about 2.5 seconds to process. And that's clearly not good enough. The TX2 is specifically made for this edge AI processing. It's blindingly fast. It comes with 8 gig of RAM, it's got a quad-core ARM processor, and 256 CUDA cores. Unfortunately, I've had this for about a year, and I hate it. It does amazing things. I've lost months of my life getting it to work. You have to flash it, you need to have it won't run from a VM, you've got to have a bare metal Linux box, hardwired connected over RJ45 to the board, and then you flash it. Nothing about it is easy. It is an amazing product to go to production with. It's $600 US, so it is not cheap. It is hard, but I've been battling with it because I want to solve this problem. That's why my most exciting thing is this. So this is the one I've actually got up here. The dev kit for the TX2 is about this big. The one I've got up here is the brand new NVIDIA Jetson Nano. Essentially, same board, same architecture, only has 128 GPU cores, half the processing power, more than enough, especially when you're in development. But it is $100 US, more than a Raspberry Pi, but very doable. But it's made for developers. Instead of having to flash it from a bare metal VM and set up a whole kit, which is why I carry all this around, it has an SD card. And you download an image on Windows, and you get Etcher, and you flash the SD card, and you stick it in the Nano, and it just works. I literally got this a week and a half ago. You can't order them. I had to beg, borrow, steal, promise to get it. They're back ordered everywhere because everyone's massively excited about them. If you were going to get into this edge AI processing, it just got a whole lot easier. And I'm going to very quickly jump in and do a quick demo of how this bad boy runs. So let's see how my HDMI swap over goes. So this is running. So I've told you all the amazing things about it. It is running full Ubuntu. So it's running Ubuntu 18.04. The big challenge for the TX2 and the Jetson Nano is they're actually an ARM64 processor, which means nothing works on it. For the moment. So anything you do, you more or less have to compile on the board. Or cross-compile. Okay, so it's non-trivial at the moment. Who wants to tell me why everything's about to get a heap easier on this kind of platform? Anyone? .NET Core 3 supports ARM64. So this is, it's kind of as an indicator of people are looking at this as a technology, as a platform, and where the support for it is going to get more and more and more. You guys can see that. I'm typing from down here, so this is going to be fun. So I'm going to do a very similar demo. So object detection. What I would use, so to make object detection work from the Nano, the old architecture was drone to out-of-the-box controller, USB connected to my laptop. Now what I'm doing is I had to go and get, it's a great excuse, I had to go and buy this. The great solution about the TX2 solution is it is drone independent. Before I got this controller, I was actually just using my GoPro. And I was taking the HDMI out of my GoPro and plugging it into my Jetson Nano via, here's my other hot tip if you want to find out how to do it, HDMI output to then process video input. How do you do that? Once again, I spent weeks researching how to do it, investigating different cards. You can just buy an adapter that is HDMI input to USB. So it's like $100. So this took a bunch of research to find, but now I've got it. It's gold. So I can take HDMI output of anything and process AI. Okay. So I'm going to cheat at the moment. But it means for your drone, I had to go and get, so this is the DJI Smart Controller, which is just beautiful to fly with. It has a HDMI output. So all of the big drones have a HDMI out. It also means a whole lot of other brands support HDMI out as well. So what I've done is I'm actually logging on. So you should be able to see I'm actually terminaled in to my Jetson Nano. Where am I? So I'm going to go to my, once again, this is on my GitHub repo. Adam Stephensen, Jetson, build, bin. Oh, it worked. Yep. Okay. Now I'm going to run. So there's the sample that I've compiled is just a detect net, and I'm going to do multi-pet. There's a bunch of different models in here. I'm going to run. So I'm going to oh yeah, detect net camera. Okay, so what this is doing is this is saying, take my video feed in, and actually go and process it through my artificial intelligence model. I'm not actually streaming it, because I've only got the one drone. I'm cheating, and I'm not using the HDMI port. I'm using a USB camera. But it's doing exactly the same thing and running the model on the board. Does anyone want to volunteer for me to walk? Ooh. So what this is doing, I can just show. So you can see it's actually going through. Thank you. Oh, the light's playing up with it. Can I do you where you're not? There we go. Oh. It's getting you. It's not getting the other ones. You can see it's highlighting. Actually, can I just get you to come and stand? I'll hold a little bit more still. Yeah, I think that streaming light is causing all sorts of dramas. It actually works really well. So this is the same idea. It's running object detection. It's running. You've got a halo, and it's able to actually go and it's drawing the bounding box and grabbing that feedback back and doing exactly the same thing, but running it on a board that's this big and is actually only being powered by 6 amps. So that's the other thing about the Jetsons is, they're powered by 5 volts. So I'm powering it on, if you're going to do it, the tip is you can't power it on the 2 amp because it'll just shut down because it doesn't have enough juice. You've got to up the meter. But what I'm going to do is build a version of this with another little 5-inch screen powered by batteries. So as I'm flying, I've got an extension down here under my controller that's actually running my object detection in real time attached to my controller. Pretty cool, hey? So this is all very doable now. And you can just go into Custom Vision, create your models, download them, and execute them. I'm going to quickly jump back for the last couple of slides. And I wanted to talk about the future. Oops. Are we up? Yep. Okay. So, that's been a bunch of work to get to the point where I can easily build a model and run it a couple of different ways from my drones. There are limitations around drones. The bandwidth availability, battery is still a really big challenge. The coverage and the lack of maturity is a real challenge. There are people who've invested a lot of money over the last 10 years, like eSmart Systems and Slant Range, that have got amazing solutions that they've invested a large amount of R&D into to get working. Getting in hasn't been easy, but that's kind of what we're working on is, how can we make it easier for people to build solutions that are going to help them along? Battery is a real challenge. There's a whole lot of new technologies coming out. So lithium metal batteries are coming. Gas-powered drones are really interesting as a technology to stay across. The idea of vertical takeoff drones that have fixed wings. Oh, you guys can't see that. Okay. Vertical takeoff drones that have fixed wings are very interesting. So these have the benefit of being able to take off vertically. So there's a lot of fixed wing drones have a lot of, a lot more maintenance issues because they scrape and their bellies drag and all sorts of things go wrong when they land. So vertical takeoff, but then once they're in the air, they actually fly like a fixed wing, which actually gives them much longer time in the air. So this is a technology we're going to see more and more and more of, particularly in commercial environments. The real challenge with drones, though, isn't technology. The real challenge is around the law. There is amazing things. I can't do my automated shark net because it's illegal in nearly every country to have an automated drone system. You need to have a pilot on every drone with his finger on the trigger, even if it's flying itself, in case something goes wrong. We were going to make, but so there should be caution, and drones are dangerous. You can fly. My Mavic weighs about 1 kilo, and you can fly it at 78 kilometers an hour. That can do some damage. Those big drones are heavy. People can use them nefariously and maliciously. So there should be regulations and there should be laws around it. But and it's exciting that we're at the stage. So the EU's just recently announced laws are going to be common across all of Europe, which is nice because at the moment you change countries and you don't know what's legal and what's illegal. But we're in the very early days. In Australia, we were going to make flying over beaches illegal. But the law was actually not put in place because of the great work that the Little Ripper Drone Company was doing. There is beyond visual line of sight is a really big challenge. Nearly every country has a law that says you're not allowed to fly a drone further than you can see it. We've got the Royal Flying Doctor Service in Australia, like Norway actually. Australia is a big place with a lot of empty space. If you get sick and you're in the middle of nowhere, we have to fly a plane to help you. There's only limited planes. So the Royal Flying Doctor Service ran a think tank recently to say, what could we do to get medicine and samples and help to people in remote areas using drones in a better way? And one of the key challenges they identified was not around technology, but around legislation. So it's an exciting time from a technology point of view, but it's also an exciting time from looking at the possibilities and actually shaping the conversation about what can be done with drones. So it's an amazing area and it's an exciting time to be in it. So, really in summary, I just wanted to call out that drones are saving, they're saving organizations literally millions of dollars. They're saving wildlife and even saving lives. If you can, don't go and buy a solution. Don't go, if you need agricultural, unless you're a software provider, there's a lot of really good, very mature agricultural drone solutions. If you're looking at doing something like power line solutions, go and contact someone like eSmart who's been doing it for 10 years. But if you do need to build your own solution, then it's getting easier and easier. With drones and IoT, the cloud part of it is easy. That's where I live. Once you're in the cloud, it's just another application. The challenges are, how do you get that data into the cloud? And that's still where we're having all of those conversations. Choose a drone. Don't go out and buy a drone and go, I've heard that this one's great or this one's great or this is the one to get. It very much is a case of looking at what is the solution and what am I trying to do, and now what is the right platform for me? And then going, there's a lot of drone companies that are specialists in flying drones but aren't yet at the solution stage. So I'm working with a lot of those people, so go and chat to people around what the right solution might be. But like everything, and that's really, why we're here today, is that, this is new, it's emerging. No one knows the hardware side, the cloud side, the embedded side. Success really takes everyone getting together. I've helped, my friend Steve Van Bodegraven, my friends, Scott Holden, I've had so much help kind of putting different pieces together to make all of this happen. And I think that's really great, a message just for this week is that, innovation takes a village. So I just wanted to say, tuss and tuck. Thank you very much. I'll be packing up and heading out the door to take questions so the next speaker can come in. But I hope you've enjoyed my talk, and thank you very much. Did any questions? We're right on time, but did anyone have a question before we headed out? Yes?
Just what about IDs? Are the drones identifiable in the air?
Are drones identifiable in the air? Yeah, I had that idea about building a machine learning model that you actually just put on your house and it faces upward, identifying drones that are flying over you. My uncle's got a yacht, and in a similar vein, my uncle's got a yacht, and he wants me to build almost the same model, but he hates having birds up in the stays pooing on the thing. So I think it's I'll build exactly the same solution. I'll just change my model to identify drones or birds. Thanks.